In this video, I'm going to go through my tool Aslon demo. I'm going to showcase some example use cases that I've found and also discuss some current limitations and problems and also what is coming next. So to get it running, it's just this one command. This orchestrates all the containers. Once that shows the worker container and notes, okay, there's the worker container, it means it's ready. So these are the two, localhost 8080, localhost 5233, and write a Python script that performs linear regression on a CSV file. Also create another file that generates the synthetic CSV file. Python script named main.py. No errors in output. Now when I run this here, we can go into this developer UI. So here's my test conditions, here's my user prompt. It's going to make an API call to generate code. Should complete any second now. There it is. So it relies on Dockerfile. That's how it runs commands. That's how it installs libraries. It's everything through the Dockerfile. Created a README, requirements.txt. It decided to install pandas, numpy, and scikit-learn. It created this file name called generatedata.py and the main.py, which is the actual linear regression. So we check here. So there was an error, but then it provides the corrected Docker file. Runs again. So this is a autonomous coding tool. Basically, it generates code, runs the code, feeds the output back to the LLM, and then the LLM corrects the issue and runs it again. And this just goes on in a feedback loop until all the test conditions are fulfilled. So there we go. So since the first time there was an error, it then provided the Docker file to correct the issue, and now it's outputting the linear regression coefficients. And it returned true. And there it goes. Also, you can see all your outputs, the LLM output directory. So this was here. So there we go. This was the generate data. This was the main.py. This linear regression. It's all saved locally. Another example could just be troubleshoot this code. If you have like a piece of code that's buggy and you don't feel like going through the whole debugging process, you can just paste it here. Let's see. Define. I'm just going to make something up off the top of my head and make an intentional mistake. Calculate mean y return x plus y divided by 2. Print x plus y divided by 2. There we go. Let's see what it does. So I gave it this user prompt, this test condition. It's going to generate code, no external dependencies. Run locally. The mean of 4 and 6 is 5. The mean of 10 is blah. So yeah, I mean, I didn't give it a very good prompt, but it still made this out of it, and it didn't even need to correct anything. It just ran on the first try. What's another example? Let me think. I don't know. Make up a problem and solve it. Also create test conditions. No errors in output. Passes all test conditions. Let's see what this does. And like I said before, of course, this is all being saved locally in the LLM output directory. This was the last run. Okay, so it generated code. Oh, it made some Flask. It made some Flask service here. Got an error, and this exposes the port. And funnily enough, this is actually working. I know this because the Flask server is running in Flask servers. When you run them, they run indefinitely. So this is actually never going to complete. It's just going to keep the Flask server running on port 5000, interestingly. So yeah, that's something. I guess you could say that's a limitation. If it's doing something like, if it's making backend code like server stuff, and the server starts running, it's not gonna quit the server. But yeah, I'll terminate this. Another example we can do is, this is another limitation, is web scraping. So I'll say web scrape harrisonmuchnick.com. That's me. If I just give it this, here's the website for reference. Let's see what it does. Start the workflow. Interesting. So I canceled that because it was taking too long, and I don't want this video to take forever. But now I'll show some other capabilities that I implemented recently. So this is going to close. If I git switch. So this new workflow I added, it enables the ability to run LLMs locally. So I'll actually show this here. So it depends on Ollama. You can also, if you uncomment this instead, you can have it running on your GPU pretty seamlessly. And the only thing you have to change for whatever model you want is you just set it here. So I've tried it with all these. I'm only on my laptop, so all the models don't run very well, except for like Llama, basic Llama 3. So if I set this here, ooh, what's wrong with that? Llama 3, oh, capital L, sorry about that. And I said, this is Llama 3 as well. So this is ready now. Now if I do Docker compose up, build, it should be using the local LLM. Oh, another thing is also I have this advanced mode here, so you can change the user prompts, which that's another thing that needs to be updated. I need to really work on these user prompts because they can be improved a lot. So now I'm going to demonstrate how this is working just completely locally. So here's my system monitor. Here's utilization. Let's try write a Python script named main.py that calculates the factorial up to 100, no error output. So if I run this here, see my CPU utilization immediately starts to spike up. Go here, show this is running. So right now it's using my CPU to run the Llama 3. I think it's probably the 1.5 billion parameter model. See, my memory's at 23 gigs. I like this. I like this feature that you're able to use any model that Ollama offers, because I know businesses, they have a lot of concerns about data privacy. So for business applications, they can completely trust this since it's running on their own hardware. Literally, this could run in like a shack somewhere in the middle of nowhere because it doesn't use any Wi-Fi if you run in local LLM mode. So this is still working to generate the code. I really hope it does it in time and doesn't time out, because that would be embarrassing. Well, I'm actually using the 8 billion parameter version. Ooh, I have a timeout set for 300 seconds, but oh, there it goes. So it finished. Oh, see, so that's the prompts cannot be. I don't think there's a universal prompt that will work on all models. So see, this is performing really bad. It didn't even create a main.py like I asked it to. It did. Yeah, what did it do? It created a Docker file, which makes a Python. Okay, so it does try to make, and then it sets an environment variable. Hello Docker. This is very strange. Yeah, that had an error. So this is this branch I'm on is the more experimental branch. It has like a lot of other stuff. Like it also you can give it the there's this folder here I created, the input folder. I didn't put anything here. It's still like very much a work in progress. So whatever you put in here, if you clone a repo or whatnot, it will use that as the starting point. And then at each iteration, it will do the directory tree. And I'm working on implementing some logic that can dynamically decide what to include in the context window. So if you have a very big repo, like the NumPy or like the astronomy repo, you shouldn't include everything in the context window. So obviously there needs to be some type of robust system to decide what to include. Okay, so this changed this. It created a main.py, ran that locally. Another error here, but at least it decided that, okay, we need a main.py here. Before it didn't have that. Failure. So now it's gonna create another fix. Also, this uses this version here, the branch I'm on now. It uses git merge with automatic conflict resolution logic. So it's a pretty robust system since it only needs to provide a snippet and then it just programmatically git merges that, and then runs the command. Oh, okay, what did it do? The output. Yeah, so see, this was a disaster with the Llama 8 billion parameter model, which I mean is to be expected. See, it got this error here, but it still returned true. But when I use the APIs of like all the mainstream models, it will never return true if there's an error in the output. So, maybe if I use the higher a model with more billions of parameters, then this would work much better, but my system cannot accommodate that right now. So anyway, yeah, for sake of brevity, I've probably already gone on too long about this, so I'll end it there. But that's essentially the current state of the project. I showcase some limitations. Web scraping, it's not very good at, unless it's a very simple web page. Determining what to include in the context window, like if you want to put something in this input directory, the system to determine what to include in the context window needs to be refined a lot more. But that's what I'm working on next. And if I'm able to successfully implement that, then I feel this tool will become much more stronger, because you could just give it a repo and say, hey, add this feature to the NumPy library or whatnot, and it would theoretically work well. So yeah, that's it.